All right, so today we're going to make the transition from unit circle trigonometry to right triangle trigonometry. So, you know from unit circle trigonometry that the coordinates of any point on the unit circle at a given angle are the cosine and the sine of that angle. All right, so the coordinates of this point here are x is cosine theta, y is sine of theta. But you can also see that as the legs of the triangle, right? Because the distance in the x direction is basically the leg of this triangle that's horizontal, right? It's going in the x direction. And the y coordinate is the distance that we're going up in the y direction, okay? So, so not only do we know that the coordinates of that point, we know the sides of this triangle with a radius or with a hypotenuse of 1, right? It's a right triangle and the hypotenuse is 1. And we also know that if we scale that triangle up by a factor of r, so that now the radius of the circle is r, then the coordinates here are r cosine theta and r sine theta, right? We learned that as well. This is r cosine theta and r sine of theta. Okay, those are the coordinates of this point on a circle of radius r. But you can also see that as the legs of a triangle. If we drop this perpendicular down to the x-axis, the horizontal distance is the x-coordinate, and the vertical distance here is the y-coordinate. All right. Now, we're going to name the side opposite the right angle. We're going to call that the hypotenuse. Okay, that's called the hypotenuse. And then given an angle, in this case theta, the side that is opposite that angle is, we're going to call that the opposite side, right? And the opposite is r sine theta, right? And the side that's touching the angle theta, this angle theta, we're going to call that the adjacent side because it's adjacent to the angle that we know. And so our cosine theta is the adjacent side. So if we rearrange that, if we rearrange this and get an expression for sine of theta, it's equal to the opposite over the r, but r is the hypotenuse. So you can see where this formula is coming from. We can derive it from what we know about unit circles. Same way with this. If we rearrange it, then the cosine of theta is equal to the adjacent side over r, but r is the hypotenuse. And so you can see where this formula is coming from. And then we know that tangent is sine over cosine. So if we take opposite over a hypotenuse and divide that by adjacent over hypotenuse, then we end up with opposite over adjacent. Okay. Now these definitions of sine, cosine, and tangent may be already familiar to you. Oftentimes in high school geometry, this is the way that trigonometry is introduced as right triangle trigonometry. You learn that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And sometimes people teach this little mnemonic SOHCAHTOA, which is just the first letters. Sine is opposite over hypotenuse, so SOH. So, and then cosine is is adjacent over hypotenuse, so that's the ka, and then the toa, comes from tangent, is opposite over adjacent. So that's just a little mnemonic to help you remember sine, cosine, and tangent in terms of the legs of a right triangle. Okay, this is for a right triangle. Okay. So that's what we're going to use today. We're going to use SOHCAHTOA. We're going to use these right triangle definitions of sine, cosine, and tangent to help us solve some problems. So let's take a look at example 1. So here, let's see, I guess we have 1a and 1b. In 1a, we're given a right triangle. We're going to assume this is a right triangle. It doesn't have a little symbol here, but I can draw that in. It's a right triangle. One of the angles is 15 degrees. This smaller angle up here is 15 degrees. And we're given that the hypotenuse is 28 feet. Okay, so, and we're asked to find this length, this indicated length with a question mark. We want to find that length. And I could call that x. Let's just call that x. All right. So, using the definition of sine, this right triangle definition of sine, I know that sine is opposite over hypotenuse, right? So I know that the sine of 15 degrees is equal to x, which I'm looking for, over 28 feet. Okay. And then I can solve for x. So then x, if I just multiply both sides by 28, I get x is equal to 28 sine of 15 degrees. And that's something I can put in my calculator. Now, make sure you have it in degree mode. If your angle's in degree, make sure it's in degree mode. So if I put it in degree mode, calculate this side length, I get 7.25 feet. Okay? So I'm just using sine is opposite over hypotenuse. Let's take a look at this next one. I'm given an 18-degree angle down here, and one of the sides is 15 meters. We're going to assume this is the right angle. And we want to know the hypotenuse now. So usually when I see these triangles, I try to think, okay, what do I know and what do I want to find? I know the opposite, and I want to find the hypotenuse. So which one of my trig functions involves opposite and hypotenuse? All right. And that's the sine, right? That's the sine. So sine of 18 degrees is equal to opposite over hypotenuse. And I'm just going to call it x. And then it's just a matter of solving for x. So x is equal to 50 over sine of 18 degrees. And I can put that into my calculator, and I get 161.8 meters. All right. So that takes care of example 1. If you want to look ahead at any of these, I think that a lot of these you may not need to walk through a lot of examples. But I'll go ahead and record these videos. But if you want to go ahead, just do them yourself and use the videos to check your work, that's fine. So, all right, I will meet you in the next video.